let's begin. Okay, I'm going to create a new project. We're going to create a new control. It's a new class. Call it color picker. It's going to extend a Windows Forms control. We're going to have to set some styles. But before we do that, let's take a look at the actual styles that are already set. The ones that we're going to look at are independent, so they're not going to inherit from the parent control or the parent form. So we're going to use get styles, debug. We're going to write it to the output window. Right line. This time get style. Control styles. User paint. And we're going to do the same thing for all painting in WM Paint and optimize double buffer. And of course I have to add the control to the form. Okay, so by default all our user paint is set to true, all painting in WM Paint is set to true, and optimize double buffer is set to false. And I think it can change up a bit. So yeah, so this time all painting in WM Paint is set to false by default. I suppose there is no real consistency, and you can't just assume that it's going to be set to a certain value by default. So we're just going to make sure all the values are set. User paint, this means that all of the painting will be done by the control itself and not managed by the operating system in any way, and that's what we want to do. And all painting in WM Paint, this blocks messages that can be sent to the control that cause the control to flicker or be cleared, and we want to enable its flag to true, and that will keep this message from being interpreted. Okay, and then there's optimize double buffer, and you know what that is. We're just double buffering the control itself. So you may have noticed that there is a property on the form here called double buffered, and you may ask yourself, well, what's the difference between this double buffered property and the set style or the style flag? And I asked Microsoft MVP, and they told me that setting the optimized double buffer flag in using the set style method to true is the equivalent of setting the double buffered property to true in a form. And then I was reading lately about this, and somebody said that they asked an MVP, and they said that it's equivalent to setting optimized double buffer and all painting in WM Paint flags to true. So we're still not quite sure what it does. So I think you're just better off setting the styles using the set style method. And you can't even do, there is no double buffered property for the control itself anyways. So let's do that right now. This set style, control styles, optimize double buffer, and we're going to have to use optimize double buffer even if we have our own double buffering logic implemented. And then user paint, and then all painting in WM Paint, and resize redraw. This will make sure that when the control is resizing, that will redraw it, because our linear gradient brushes are going to update when we resize them, and we want to draw when we resize the form itself, so we have this new higher resolution or smaller resolution of this linear gradient brush. And we're going to use typical back buffering, because we will need to access the canvas to get colors from its pixels. So typical back buffering it is. I have videos on this as well if you need to learn a bit more about the back buffering. And I also have benchmarking for the buffered graphics back buffering and typical back buffering, which is what we're going to use now. Okay, so we need to create a bitmap we're going to call this canvas, and this is going to be our drawing surface and what's also going to be drawn to the control itself. And our back buffer, which will be a graphics object. I'm going to call it graphics buffer because it's pretty obvious that it's in the background. It's not the fore buffer or the screen. And that would just be redundant to call it a back buffer. I still call it a back buffer in the video. Okay, and after that we need to create some linear gradient brushes while we're up here. So linear gradient brush, and unlike the control that I've made previously, we're going to have two linear gradient brushes. So LGB spectrum and LGB fade, and we'll go over what these two do later on. But right now let's make our back buffering method. So private void update back buffer. Those are two different words, I suppose. I call the methods update and whatever because we're basically going to be using them to update certain objects. The only time we're not going to do this is in the constructor, and that's not quite updating, we're just doing the initial assignment. Okay, and when you're using typical back buffering, you always want to test to see if the form has been created, and you can do that by testing to see if the width is greater than 0, because it will be 0 sometimes when you try to create a back buffer and you'll get an error. And of course, testing a integer for equality is actually the fastest way, and just dealing with numbers in general is faster than testing for null or anything like that. So you might even want to do this if you want to get really picky. Okay, so let's assign to our graphics buffer. Actually, before we do that, we're going to create our canvas. So bitmap is equal to this.clientSize.width. Now, since we are using a panel and we could possibly have borders, these borders will account for a bit of the size, maybe 2 or 1 pixels or 3 pixels on either side of the control. We want to use the client size instead of just the normal size. So our calculations are a bit more accurate. And this, if we decide to use the normal size and like throughout the entire control, you may have problems where the user will scroll through colors near the borders of the control and a random exception will occur. So to be safe, we're using client size. And this dot client size dot height. This is going to create a blank bitmap with the appropriate size, and you kind of have to pass in your parameters separate like this. There is no overload accepting a single size. Now let's assign to our graphics buffer. The graphics buffer is going to be created from the canvas, because that's what we want to ultimately draw to. We're going to pass in our canvas, and that should do it. Now we're going to create a method called update gradients. Our gradients need to be adjusted to the size of the form so they don't degrade and we don't have to stretch them as a bitmap. And that's what we're going to do using this update gradient method. And it's also going to be responsible for its initial construction of the linear gradient brushes. So we're going to start off with the LGB spectrum. So LGB spectrum is equal to new linear gradient brush. And we need to use the rectangle. No, we don't. We're just going to use points. So we're going to start off with point.empty, and we're going to create a new point. This dot client size dot width, and 0 on the Y. So that's just going to give the linear gradient brush a direction to travel in. And now we need to specify some colors with this overload. kind of have to, and it doesn't really matter what colors we specify. These are the linear colors, and we're not going to be using them. We're going to specify our own blend. Okay, let's begin creating our color blend. Our color blend is going to allow us to create our LGB with more than 2 colors. By default, those last 2 colors in the parameters of the constructor represent the linear colors, property, LGB spectrum, linear colors. There we go. Gets the starting and ending colors of the gradient. And if you set these anywhere and you have your blends set, the blends will be used in opposed to these start and end colors. So let's set our blends. So we're going to create a new color blend object. I'm going to call it spectrum blend. And we've got 2 things here that we need to set. We need to set our colors and the positions. So let's set our colors first. For the time being, we're just going to use RGB, red, green, blue. And this is a color array. So new color array. Create a color array. Color.red, color.green, color.blue. Okay, spectrum red. Positions is equal to new float array, and now we need to specify our positions of the colors in the gradient. So with every any kind of colors that you're using, you need to specify the initial position and the last position. So the initial position, which is going to be the leftmost color, I do believe, in our gradient, is going to be at position 0. So this float here represents a percentage, really, of how far along from this first point it is, the color, to the second point. So the gradient at this point here should be 0, and the gradient at this point here should be 1, being 100%. Or it could be the other way around, but it doesn't really matter as long as all the colors are in there. So there, we've got our first and second position defined. Now we need to define all of the positions in between, which would be the green color, the color green. And that's going to be dead center. So we're just going to put 0.5. When you're using more colors, the format of this is going to be a bit different. Okay, now let's assign this new blend to our LGB spectrum. Blend is equal to spectrum blend. Okay, sorry. That was the blend property. I need to assign this to the interpolation colors property, which is the actual color blend for multicolored gradients. Okay, in the constructor, we're going to call update backbuffer and update gradient. And you can get away with not doing this, but every once in a while you're going to start up the control or dragging control under your form, and you're going to get errors all up in your program unless you do this. It's just good. It's just a good thing to do. So let's call them as well in the onSize change event. So protected override onSize changed. OnSize changed and onResize are pretty much identical from what I've read, but you never know. You'd have to do some experimenting yourself to really know. Okay, and update gradient and update backbuffer. You don't want to update these things in the onPaint. That's just unnecessary. It's not going to be called, these aren't going to be called much more than they are now if they were in the onPaint, but it's just more readable because these methods only need to be called when the size changes in the control. So let's override the onPaint method as well. Protected override onPaint. And in the onPaint method, we're going to draw to our backbuffer. So graphics buffer, we want to fill rectangle, and we're going to pass in our spectrum, LGB spectrum, and we're going to pass in the client rectangle of the control, which is going to be everything except for its borders. And I don't know if I told you, but I decided to use the panel to extend from the panel control so that we can set the borders of the control, and it actually looks pretty nice. You can't do this just with the control. Okay, graphics buffer. Actually, I can't do this right now because I did not set my other linear gradient brush, but we're gonna make it functional and run it and see how it's doing. So e.graphics.draw image unscaled. You want to use draw image unscaled because you're going to get more performance out of it in relation to draw image. And we're going to pass in our canvas. Our canvas is what's being drawn to, so if we call fill rectangle on our graphics buffer, we are filling a rectangle with a gradient in it on our canvas, being the drawing surface. And we're going to draw it at 0.00 on the surface, or sorry, on the form. Now let's drag this control. It's already on there, but let's drag it there and take a look at it. So you've got gradients red, green, and blue, and let's anchor it to see how it resizes. There should be no flicker. Good. Now let's begin writing our overlay gradient. And this is going to provide the user with selecting darker and lighter colors and white and black. So down in the update gradient, I'm just going to comment the top here. Call it update spectrum. And here we're just going to say update overlay. You can call it overlay, fade, or dark white, whatever. So let's assign to it, and it's actually going to have the same construction as the first one up here. Doesn't really matter. Now in my older videos I was using 3 gradients, and this is unnecessary. You can use a single fade white black gradient, just have white at the top or black at the top and then the other color at the bottom, and you're fading in towards transparency. So let's do that. And I'm just going to copy all of this stuff here to use it as a template because that's how I roll. So I'm going to change this to fade blend and just do some copy and pasting. Okay, very good. Now we have everything set except for our colors and our positions. So one of our colors at the end needs to be black, and at the other end it's got to be white, and in between we can have the color transparent. And we do need to change the angle to 90 degrees for this to be applied properly. So what we're going to have to do is, with this overload here, with the points being specified, there's no corresponding overload to specify the angle. We have to actually use a rectangle. So let's do that right now. Rectangle rect is equal to new rectangle, and we're going to pass in an empty point and the size of the control. So this dot client size. Actually, we may be able to get away with doing this. Now let's take a look at the overloads to find what we want. So here's a good one right here. We've got a rectangle and then our color and then our color and then our angle. That's simple enough. Now remember, these first 2 colors here will be disregarded by the program. And we're gonna draw this gradient at angle 90 degrees. And I actually have to draw it, so let's go down to the on paint method and draw this gradient. So fill rectangle, LGB spectrum, and opposed to using or painting the LGB spectrum brush, we want to use the LGB fade brush. And we're going to get a nice black to white fade, and it can be easily adjusted, like the bounds and whatnot of the white and the black can be easily adjusted with the linear gradient brush positions and whatnot. It's a bit easier than what I had it before. Okay, now let's create some functionality to actually be able to select colors. So private color selected color. So the first thing that we're going to do is define a hook for an event. So public event, the event keyword is going to give the event handler or the delegate type an unsubscribe, subscribe kind of behavior, so we can hook to it effectively like every other event. So event handler, and we're going to call this color picked. Now let's define the event. So private void, it has to start with the word on and be the same name as the delegate type. So this event handler here is just a predefined delegate type that points to events that have the event args and the sender, or maybe just the sender. I have a video on this. You can watch that if you're not familiar with how all this works. And we don't need to pass in any arguments or anything, so I'm just going to get on to creating it. Color picked. So if color picked is not equal to null, so if there's something actually subscribed or hooked to this event, we want to call its defining code. And we're going to send this in as the sender. That's typically what the sender is the object or the instance that has raised the event. And event args, we don't need to use any event args because we will be exposing the selected color as a property, and the user of this control can access this property after the onColorPicked event has been raised to get the selected color. So public color, selected color, get return selected color. Now we need to do another override. I've got all my overrides together just because that's how I roll. On mouse click, that's what we want to use to select a color. We're going to first raise the on color picked event, and then we're going to, actually sorry, that's wrong. We need to assign to the selected color. So we're going to use the getPixel method, and this method is an instance method for the bitmap class. We need to use client coordinates for this, so I'm going to do that right now. Point pose is equal to this point to client cursor dot position. Cursor dot position returns a screen coordinate for the cursor's position, and you need to convert it to the client coordinates. So it's relative to the form or to the control. In our case, it's going to be a control being this. And that's what it is. So pose x, pose.y. Okay. And we're going to register to this or hook to this event so we can actually change or see how the control works. So I'm going to go to its events and look for color picked. Double click on that, creating a handler, and this dot back color is equal to color picker dot selected color. So now when I click on a color in the color picker, it's going to reflect on the form's back color. You can pick brighter colors in white and black. Now we're going to add a cursor just to take a break from code to this project here so that we're not using the basic cursors images. So go to the project properties, resources, just hit add existing file and go find some fancy cursor file. I think mine was found in a redistributable folder in one of the developer tools I have, probably Visual Studio 2010. I don't know. I found it with my file finding program when I just searched for cursors. So this is going to be my control in my end user base directory with my end user programs and the extractor here. And I'm going to go down here, hit all files so I can see the cursor, and I'm going to add that to my project. Now, of course, this cursor file is not a text file, and it's not an image, and it's not anything else, so it's just going to be a binary file type. And it's going to be presented to us in the project as a byte array, and I'll show you how we can utilize the cursor as a byte array. So in the color picker control, we're going to use our cursor here. So using memory stream, now pass in the resource as a byte array to our memory stream. I'm going to add the namespace here. And there's our cursor right there, the color pro cursor, and it is a byte array. This.cursor is equal to new cursor, and one of these constructors will allow us to pass in a stream, so we're going to pass in our memory stream. And that will allow us to use our own little defined cursor or provided cursor. And it looks very nice. Okay, now we need to define a method that will allow us to have a hover color. So let's do that right now. Public color get hover color. It's going to be similar with what we've done in the on-mouse click event handler, except we're going to use it here, and instead of assigning to the selected color property, we're going to return it and not raise the onColorPicked event. And I'm just going to copy this client position here. We're just going to return color empty, and then in the form we can hook to the mouse move event of the control, and do something like this. This.backColor is equal to color picker hover color. Actually, we should not do that. Going to test for empty, or is not empty. So if color is not empty, then we want to assign it to the back color of the form. Okay, there we go. Like above, we're also going to have to test the alpha to see if it's equal to 255, because getPixel for some reason does not return an empty color if it detects something like a color that it can't interpret, like when you're loading up the form and your mouse is over the form or something like that. It returns a weird empty color. That's what I'm saying. There we go. Oh yeah, and color empty, I do believe, is going to yield a color that has an alpha that's not 255. It's going to be 0, so I don't think we need to test for is empty. Yeah, I'm pretty sure color.a is equal to 255 will account for both is empty and whatever getPixel returns. Now we need to actually define our full spectrum instead of just red, green, blue. And I'm going to go open up another project. So I'm opening up the color extractor. Go to the full color picker. Here it is. So here's the full color spectrum, and all I need is the colors and the positions. So I'm going to replace my positions and colors right here with the new information. Let's take a look at that. So this is the more effective color spectrum. You're going to have your grayscale here on the right, and then you're going to have your pink on the left here. Goes through the entire color spectrum. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 8 colors defined. We have how many positions defined? 1, 2, 3, 4, 5, 6, 7, 8. So you should have the same amount of positions as colors. And so right here, I'm specifying positions using division here is an easy way of doing it, or keeping it organized. So let's go to the center here to see how it works. So 4 divided by 8, that's going to be 0.5, and that's going to be the color at index 4. And of course, 2 divided by 8, that's going to be like 25% into the control, I think. I'm not so sure. But anyways, this is the easiest way to do it, specifying your positions from 0 to 1. And this is your colors, your possible colors that you want to blend for a full color spectrum. You can exclude the gray and have 7 colors, and then have a second gradient, like a smaller linear gradient, just like in a rectangular region at the bottom here. I've done that before. Or maybe a separate color spectrum to represent the grayscale. And that's it for this control. See you later.